SQL interviews are not about memorizing syntax. They are about recognizing patterns and turning messy business questions into clean queries. In this video, we will solve 15 real SQL challenges with input tables, expected output, and clear explanations. We start with the most common interview pattern, selecting only the rows that match a real business condition. A support team often needs a clean list of customers who can still receive service. Let's create a small customers table, add mixed statuses, and then filter only the active rows. Now we run the script and look at the result. Let's break down why this works. SQL reads from the customers table, then the where clause removes every row where the status is not active. That is why inactive and blocked customers do not appear in the output. Now let's show the best practice. In real projects, select the columns you actually need instead of using select star. It makes the output clearer and avoids sending unnecessary data. Here's a quick variation to try yourself. Change the filter from active to inactive and check that only Noah Brown is returned. This helps you practice changing business rules without rewriting the whole query. Next, we control result order, which is essential when a dashboard needs the newest records first. An operations dashboard usually wants the most recent activity at the top. Let's create an orders table, insert several dates, then sort from newest to oldest and keep only 5 rows. Now we run it and check the output. Let's break down the result. DATEAC puts the largest, newest dates first. So April 8th appears before April 6th and April 5th. Limit then cuts the sorted list down to exactly 5 rows. Now let's show the best practice. Whenever limit is used for a meaningful top list, always add order by. Without ordering, the database is free to return any 5 rows. For practice, reverse the direction, use ascending order and limit the result to 3 rows, so the output shows the 3 oldest orders. This is the same pattern with a different business question. Now we move from individual rows to summaries, starting with counting records per group. A sales analyst may need to know which customers are ordering most often. Let's insert repeated customer IDs into an orders table, group those rows, and count how many orders each customer has. Now we run the query and inspect the group result. Let's break down the grouping. All rows with customer ID 1 are placed into one group, so the count is 3. Customer ID 2 has 2 rows, and the remaining customers each have 1 row. Now let's show the best practice. Aggregate expressions should have clear aliases, because names like CountStar are hard to read in reports. The alias order count tells the next developer exactly what this number means. For a quick variation, add a row-level filter before the grouping. Try counting orders only where customer ID is greater than 1. This shows how filtering and grouping can work together. Next, we filter grouped results, which is where having becomes important. Marketing teams often want customers who spend above a certain amount. Let's group orders by customer, calculate total spending, and keep only totals greater than $500. Now we run the query and look at the high-value customers. Let's break down why only 2 customers appear. Customer 3 spent $600 and customer 1 spent $570, so both pass the having condition. Customers 2 and 4 are below the threshold, so they are removed after the totals are calculated. Now let's show the best practice. Use where when you filter original rows and use having when you filter calculated groups. This keeps aggregate queries easier to read and easier to debug. For practice, lower the threshold to $250. Customer 2 should now appear because their total is $265. This is a simple way to test that having is filtering the totals. Finally, in this batch, we combine rows from 2 related tables with a join. Reports often need readable customer names instead of just numeric IDs. Let's create customers and orders, then join the order rows to the matching customer rows. Now we run the script and check that each order has a customer name. Let's break down the join. Each order has a customer ID and the join compares that value with the customer table's primary key. When the values match, SQL returns one combined row with order details and the customer name. Now let's show the best practice. Use short table aliases and joins, especially when columns come from more than one table. Aliases like O and C keep the query readable without hiding where each column comes from. For practice, add a customer who has no orders and run the same inner join again. That customer should not appear because inner join only returns matched rows. This is a useful check before you move on to left join. Now we move into missing related data. This pattern is common in interviews because it tests whether you can compare two tables and find records that do not have a match. A retention team may want to find registered customers who never placed an order. We create customers, create orders for only some of them, and then use a left join. Now we run the query and look for rows where the joined order ID is null. Let's break down why this works. The left join keeps every row from customers, even when there is no order. For Ben and Diego, SQL cannot find matching rows and orders, so order ID becomes null and the where clause keeps exactly those rows. Now we show the safer version of the idea. When checking for missing related rows, filter on a joined column that should never be null when a real match exists. A primary key like order ID is a good choice. For practice, flip the task around. Return customers who have placed at least one order, but make sure each customer appears only once. This tests whether you understand both matching and duplicate rows after a join. Next, we calculate a business metric. Interviewers often use these tasks because the SQL is short, but the filtering logic really matters. Average order value is a common e-commerce metric, but it should not include canceled or refunded orders. Here we insert several order statuses, then calculate the average only where the status is completed. Now we run it and check the rounded result. Let's break down the result. SQL first keeps only the completed rows, then AVG calculates the mean amount from that filtered set. Round makes the metric presentation ready with 2 decimal places. Now we show the business rule that protects this metric. Revenue calculations should exclude canceled, refunded, and test records before aggregation. Otherwise, the number looks precise, but it answers the wrong question. For your variation, add 1 completed order for 300 and 1 canceled order for 300. Rerun the query and confirm that only the completed order changes the average order value. Now we handle a data quality check. Duplicate detection is a practical SQL skill because bad source data can break reports, migrations, and user accounts. Duplicate emails are a classic data cleanup problem before a migration. We create customers with repeated email values, then group by email and count each group. Now we run the query and keep only emails that appear more than once. Let's break down the logic, where filters individual rows, but here we need to filter groups after counting them. That is why having count star greater than 1 is the key part of the query. Now we show the practical improvement. Real email data often has mixed case or extra spaces, so normalize values before checking duplicates. This prevents the same address from being treated as different text. For practice, add a row with the email written as uppercase benexample.com. Then update the query with lower and trim so it still counts as the same duplicate email. Now we move to ranking problems. These are interview favorites because they reveal whether you understand ties and distinct values. The second highest salary task gets tricky when multiple employees share the same salary. We add duplicate top salaries and duplicate second salaries, then use dense rank over salary descending. Now we run it and return everyone whose salary has rank 2. Let's break down the ranking. The salary 1000 is the highest distinct value, so both Ben and Chloe get rank 1. The next distinct salary is 1000 5000, so Diego and Finn both get rank 2 and both are returned. Now we show the best ranking choice for this question. Use dense rank when duplicate values should share the same position and the next distinct value should be the next rank. That matches the phrase second distinct highest salary. For practice, replace dense rank with row number and run the query again. Notice that only one employee can get row number 2, which changes the meaning of the answer. Finally, in this batch, we combine aggregation with a window function. This is a realistic reporting pattern for product analytics and revenue dashboards. Product revenue ranking is common in analytics reports. We first multiply quantity by unit price and sum it per product. Then the outer query ranks those product totals. Now we run it and check which products are tied. Let's break down the 2 stages. The CTE turns many order item rows into 1 revenue number per product. Then rank orders those revenue numbers and the 3 products with revenue 100 all share rank 2. Now we show the safer structure for this pattern. Aggregate first in a CTE or subquery, then apply the window function outside it. This keeps the query readable and avoids mixing row level and grouped logic. For practice, change rank to dense rank and compare the final rank for product 101. This will show the difference between leaving gaps after ties and keeping ranks compact. Now we move into analytical queries, where SQL is used not just to fetch rows, but to calculate business metrics over ordered data. A finance dashboard usually needs cumulative revenue, not just daily numbers. Let's create daily sales data, then use sum as a window function ordered by sale date. Now we run the script and look at how the total grows row by row. Let's break down why this works. The window does not collapse rows like a normal group by would. Instead, each row keeps its own date and revenue, while sum looks backward through the ordered window and calculates the cumulative value. The best practice here is to make the window order deterministic. If two rows have the same date, the database may choose either one first, unless you add another ordering column. In production, order by sale date and a stable ID when the sequence matters. For practice, add a sale ID column and create two sales on the same day. Then calculate the running total ordered by sale date and sale ID, and check that the cumulative values are stable every time. In time-based analysis, interviewers often ask how to compare each event with the event that came right before it. When you compare customer behavior over time, each order needs to look at the previous order from the same customer. Let's create a few orders and use lag to bring the previous amount onto the current row. Now we run it and check the change column. Let's break down the result. Customer 101 has 3 orders, so the second row compares against 80 and the third row compares against 125. The first order for each customer has no previous order, so SQL correctly returns null. The best practice is to partition by the entity you're analyzing. If we forget partition by customer ID, the previous order could belong to a different customer, which would make the comparison meaningless. For your variation, calculate % change instead of $change. Use the previous amount as the denominator, and be careful with null for the first order in each customer's history. Top N per group queries are common in interviews because they test aggregation and ranking in one practical problem. This is a classic marketplace interview query. Find the best-selling product in each category. We'll join products to order items, calculate total revenue, rank products per category, and then keep only the first row. Now let's run the query and inspect the winners. Let's break down the algorithm. First, we aggregate revenue at the product level because ranking raw order rows would be wrong. Then, row nunter starts over for each category and puts the highest revenue product at number 1. The best practice is to use row nunter when the business wants exactly one winner per group. Notice the extra product name sort after revenue. That tiebreaker makes the result predictable if 2 products have the same revenue. For practice, change the final filter from RN equals 1 to RN less than or equal to 2. That turns this from top 1 per category into top 2 per category without changing the aggregation logic. Gaps and islands problems are about finding continuous ranges in data, such as login streaks or active subscription periods. For retention work, a single login is less interesting than a streak. Let's create login events, including a duplicate same-day login, then deduplicate by user and date before finding consecutive ranges. Now we run the script and look for streaks of at least 3 days. Let's unpack the key idea. For consecutive dates, the date minus the row number stays constant inside the same streak. Once there is a gap, that calculated key changes, so group by can separate one island from another. The best practice is to deduplicate before calculating row numbers. If one user logs in twice on the same day, that should still count as one active day. The query does that in the distinct login CTE. For practice, change the having condition to count at least 2 days. User 3 should then appear because that user has a 2-day streak from March 10th to March 11th. The final task is a case-style analytical query, where the clean solution is usually a chain of small CTEs. This is the kind of case query you may get in a product analytics interview. We need each sign-up month, the number of users in that cohort, and how many returned in the next month. Let's build it with CTEs and then run the full script. Let's break down the result. January has 3 signups, and users 1 and 3 were active in February, so retention is 2 out of 3. February has 2 signups and 1 returned in March, while the March cohort has 1 user who returned in April. The best practice for this kind of interview query is to split the logic into named CTEs. One CTE defines cohorts, one finds retained users, one counts cohort size, and the final select only formats the answer. That makes the query easier to debug under pressure. For your variation, calculate same month activation instead of next month retention. That means activity should happen in the same month as signup, not the following month. Keep the CTE structure and only change the activity month condition. You just practiced 15 SQL query patterns that appear again and again in interviews and real developer work. If this helped, like the video, subscribe to Dev Level Up, and comment what SQL topic or challenge set you want next.